Hello, I'm Nick. I will be doing Coder Beginner Contest 417 and trying to explain what I'm doing along the way. Haven't done beginner contests on Coder in a long time. I'm assuming that most of the problems are not interesting, but I'm hoping that I will be doing Coder regular contest tomorrow also with commentary. So check on that if you are interested in that kind of content. But for now, Coder beginner contest. Problem A substring. You're given an n character string s consisting of lowercase English letters. Output the string of n minus a minus b characters obtained by removing the first a characters and the last b characters from s. Well, okay. Shouldn't have put microphone here. I don't know. Let's put it behind the keyboard. Okay. Now I can type actually. For all the people who asked me why I'm not using scene, I can, but I'm just used to this kind of. Okay, the string has method substr. The parameters are the start and length, I think. Okay, problem B. Takahashi has an integer sequence of length n. It's guaranteed that a is non-decreasing. Takahashi performs m operations on this integer sequence. In each operation, he performs the following operation. Bit of too much operations in this line. In the sequence, if the sequence A contains bi as an element, select one such element and delete it. If no such element exists, I think I would say elements exist, but I'm not sure. Note that since A is non-decreasing, the sequence after the operation is uniquely determined regardless of the choice of element and remains non-decreasing. True. Just wanted to say that, but it's problem B of Coder Beginner Contest, so I guess we just asked to do stuff. And n and m are so small that you can physically do it in linear time on every operation. But it is not necessary. We can do it faster. Basically, we are given a starting multiset and then some elements to remove from it. The order of removals doesn't matter, so we can just for every element count the number of times it occurs, subtract for every b until it becomes 0 or until we run out of b, and then print all the elements we have remaining, or we can use std multiset to do the same. In both cases, the complexity will be n plus m times logarithm. I guess you can technically use an ordered map. For the first thing I said, like for maintaining the counts, we need a map because values are big. I guess you can use unordered map. There is like a bit of an issue that we need to print the resulting sequence sorted, because like we know that it should be sorted, and unordered map by default will not provide such an opportunity, but we already know the sorted order of those elements. Like it's array A. Some of them will not exist anymore, but using unordered map and the given sorted order A, we can solve this problem in linear time. But like I don't like using unordered map because it's not much faster by default. Like if you just use std unordered map, it has such a bad constant factor that like it is not much of an improvement, and it can be hacked like by anti-hash tests and stuff. There are like faster hash maps that are actually faster than std set and std map, but like it requires either writing some code or some pre-written code. So I'm trying to stick with sets and maps unless like I need that better complexity for some reason. It's not frequent that you actually need to use unordered sets or maps. Usually just set and map are enough, and like even though they're not fast either, at least they have like proven complexity, so you can be sure that it won't be slower for some reason. So I guess I'll stick with std multiset. That's not what I want. So we insert all of our initial elements into the set, and then read the elements we need to remove. Then erase. We need to erase just one of occurrences, so erase of actually that find, and then just print the elements in increasing order, non-decreasing. I kind of find it weird that like checking if the element is in set or multiset, like by default done with this like weird instruction. I usually prefer writing like count to check if the element is in set. Like it returns the number of times it occurs, but like if it is non-zero, then it is in set, otherwise it isn't. And usually I'm using like set, not multiset. So, but for multiset, this count method works in log of size of set plus the number of occurrences. Like it basically does like lower bound, and then it iterates for all the elements that are equal to x until it like stops, until it finds all of them. So like in the set, like it doesn't store like how many elements there are. It just stores all the elements in sorted order, and there are ways to like do lower bound and then like go to the next element. But it cannot like calculate the number of elements. It cannot like do lower bounds and upper bound and take difference between them. That's not how set works. So like it would require some stronger data structure, like some uh, tree or something. I mean, set is also like a self-balanced tree, but it does not uh, maintain like the sizes of subtrees and stuff. Um, at least you cannot look at them. So yeah, for like basic balanced search tree, uh, it, it should not be possible to calculate the number of times some element occurs fast, because like that's just not in the specification. So for multisets, yeah, this can be slow. Interesting. Problems usually like don't like empty outputs. Like for some I don't know, maybe for some languages, something like leaving the output empty can be tricky, I think. Okay, problem C. Given an integer sequence A of length n, find how many pairs of integers ij satisfy j minus I is equal to ai plus aj. Finally, the input is big, and it's not even like super clear how to solve this. So the elements are positive. We probably want to like put everything with I on one side and everything with j on the other side. So if we move I here and aj to the left, it will be j minus aj is equal to ai plus I. So we can go left to right, maintain in like some kind of map how many times we have seen like for each value ai plus I, and then for potential j we calculate j minus aj and look up that map and add that value to the answer. Okay, so problem C already is not like implement what is written in the statement in any way. That's not that bad. I guess I don't actually need map because the values are small. So I can just use an array, but I need to be careful because like j minus aj can become negative, but I plus ai will be positive. So values of I plus ai can become like up to 4 times 10 to the fifth. And also the answer can be long, I think. Maybe it cannot, actually. I don't know. Like it's kind of... No, probably you can like make half of elements like to be potential I and half of the elements potential j. So yeah, it can be like n squared so the answer must be long. Okay, technically in this problem, like, we are doing math on indices, so like it is kind of important that they're from 1 to n, not from 0 to n minus 1. But since we only take difference of them, like it wouldn't matter if we shift them by 1, even though like we rearrange that thing, like it wouldn't matter if we shift all the indices by 1 in the original equation, so like after we change something, it still doesn't matter. But like for I don't know for what reason, but like technically you need to be careful and like use one indexation when you're like doing actual like math on indices that is written in the statement. Like if you're doing math on indices in terms of like determining the distance between two positions in the array, like that doesn't matter, like because the math is like contained in the like the representation you are using. But if the math is like written in the statement, you need to like use what's written in the statement. Like for example, if it was like plus here and minus here, the problem wouldn't change much. We'd like still separate like all the i's and all the j's, and like the solution is pretty much the same. But like then it would matter that that the indices were from 1 to n, not from 0 to n minus 1. Okay, so we need to try treating this position as j, so like we have to answer the number of times index minus x occurred, but we need to be careful to not go to the negative indices here, so we do that only if I is at least x, and then we treat it like potential I, so sin t of I plus x plus plus. So in this problem it doesn't matter again, but like the order is kind of important, since I is strictly smaller than j. We need to make sure that when we are treating some position as like potential j, all the i's we store should be like strictly to the left. So for every element we first treat it as j, because like our CNTs now store like for all the strictly previous positions, and then we add this one. In this problem it wouldn't matter because like those two values cannot be the same, because all our AIs are strictly positive. So like we cannot use the same position for like as both I and j, so we will not overcount anything. We shouldn't, but you need to think about those types of things. Problem D, Takahashi's expectation. Takahashi will receive n presents. He has a parameter called mood, which is a negative integer, and his mood changes every time he receives a present. Each present has three parameters: value p, mood increase a, and mood decrease b. His mood changes as follows based on those parameters. When the value p of the received present is greater is greater than or equal to his mood, he is happy with the present and his mood increases by A. When the value P of the received present is less than his mood, he is disappointed with the present and his mood decreases by B. However, if his mood is originally less than B, it becomes 0. The is present he receives has value Pi, mood increase AI, and mood decrease Bi. You're given Q questions, so answer all of them. In the ith question, you're given a non-negative integer xi. Answer the following question. Find Takahashi's mood after receiving all n presents when his mood is initially xi. N is 10,000, Q is 500,000. But also, like, the values are kind of small. Yeah, it's probably important that the values are small. It's like, if we start with some very high value, it will only decrease up to some point because it's too big. And when it stops decreasing, it will become smaller than 500. Right? So we can probably like calculate kind of DP. What will be the mood in the end if like we have already processed first I presents and current mood is X, but for X only up to 500. And the like the idea there is that if our mood becomes greater than 500, then we know that it will decrease until it becomes less than 500 again. So we can kind of do some kind of binary search to find that point and then start from there. I guess it would be simpler to make this DP like with moods up to 1,000, because if the mood is like below 500 but then we add 500 to it, it will stay below 1,000, and like it's easier to just have that calculated. And then in the start, if our mood is higher than 1,000, we will just find the first place it becomes lower than 1,000 with binary search and prefix sums. And then from there, the answer is already calculated. And for all the values that below 1,000, we understand the change right now, and we know that the next value will also be below 1,000, because if it's below 500, then it will stay below 1,000, surely. If it's higher than 500, then it will decrease for sure. So yeah, that's what we will do. The memory limit 1 gigabyte. Okay. Okay, so after all the presents, the current mode is the final mode. And now we will iterate back. Iterate over the current mode, and then we do what's written in the statement. If the current mode is at most AI0, then it will increase, otherwise it will decrease. So if it will increase, then dpix is dpi plus 1 x plus ai1. Otherwise it will decrease by ai2, but it cannot become smaller than 0. So dpyx is dpi plus 1 max of 0 and x minus ai2. Okay, so now at any moment in time and for any mood up to 1000 or like up to 1010, we know what will be the final mood. So now to answer the query, if the query value, the initial mood is small, we just look up the table. Otherwise, we know that it will decrease, and we want to find the first place when it becomes smaller than m, and we can look up the table. So to do that, we will calculate prefix sums. So we are interested in the value of decreases. Okay, so we start with x. We can assume that it is bigger than m, otherwise we will just stop after 0 operations. So we want to find the first prefix sum such that if we subtract it from x, the result will be smaller than m, which is like x minus m plus 1, because I want strictly small. So this p can be like after all the like prefix sum in n. That means that like we do all the decreases and the mode is still big, but then it's the answer. So if p is n, just print the answer. You can say x minus equal to p. So yeah, then x is the answer. Otherwise, we have process the first p presents, and our current mode is x, and it is smaller than m. And now we can just use our pre-calculated answer. problem E. A pass in a dictionary. You're given a simple connected and directed graph G with n vertices and m edges. The vertices of G are numbered vertex 1 to n. The E's edge connects vertices ui and vi. Find the lexigraphically smallest simple pass from vertex x to vertex y in G. That is, find the lexigraphically smallest among the integer sequences P that satisfies the following conditions. It is a pass, so like the neighboring vertices are connected by an edge. It starts in x and ends in y. It must be a simple pass. Okay. One can prove that such a pass exists under the constraints of this problem, because the graph is connected and there is a finite number of simple paths. Therefore, there are a finite number of simple paths from x to y, and therefore there is a minimum of them. I wanted to say that, like, if it's just a path, then it might not, the smallest one might not exist, because like it might be like not good to go outside of like smaller vertices, but because it must be a simple path, it exists. What are the limitations? N is up to 1000, M is up to 50,000. So like O of NM is good. Okay. When we want to find lexigraphically small something, it means that like we must behave greedily. We must minimize the first element, then the second element, then the third element, and so on. But we need to be sure that like it's possible to continue with our current prefix. Basically, we're building sequence one element at a time, but we need to be sure that like after we choose our next element, we have like this prefix of the sequence. We need to make sure that it's possible to finish the sequence. So in this case, it means that, okay, we start in x because we have to. Then for every next element, we try to go to the smallest possible neighbor, and then we need to check that it would be possible to reach the end without repeating any vertices. Okay, so the stupidest way would be to just try the vertices one by one. Like we have some prefix, we're staying in the last vertex in this prefix, we try on all the neighbors, then to check the neighbor, we delete all the vertices on the prefix, and then check if we can go from there to y, like on the remaining vertices. But that would be like m squared, because basically in every vertex we might try all the neighbors. The total number of neighbors is like 2m, and for every option we need to like run some graph algorithm like GFS or BFS, whatever. Instead, we can be a bit smarter and notice that actually we don't like when we are staying in some vertex, when we try to go to some neighbor, we will remove the vertices we already have and then check if like this vertex is connected to the end. The vertices we're removing do not depend on the neighbor we're choosing. So we can just remove them first and then run a DFS from the end to see what nodes are connected to it. And then we should just go to the neighbor with the smallest ID among those that are connected to the finish. That would be like for every vertex on our path, we are running DFS something. So that would be n times m, and that is good enough. There's multitest, right? Yes. And then start, finish, and address. Okay, so we have a graph. We're standing in S. We want to go to T. So while we didn't arrive, we want to try to find what's the next vertex we should go to. We're marking the used vertices that are already like on the path as bad. And since we're adding vertices one by one, it just means it marks the last one we added. Then clear the used and then run DFS from T. That will only use like non-bad vertices. And now looking at all the neighbors of S and choosing the smallest of them that can be reached from T. To do it simpler, we can sort all the adjacent lists. So now we just want to find the first neighbor that is good for us. I don't even need to print the length of the path. So instead of storing the answer, I could have just printed it. Okay. And once I reach t, I cannot go further because I will not be able to return to t, and I need to finish t. So if it's not bad and not used, we just go there. Problem F, random gathering. Explanation of sample input output 1 wasn't correct, it has been fixed. Okay. Problem of random gathering. There are n plates arranged from left to right as plate 1 to n. Initially plate I contains AI stones. You will perform M operations on these plates. In I's operation, to integers Li and Ri are given. The following operations are performed in order. Remove all stones from the plates from Li to Ri. Uniformly randomly choose an integer between Li and Ri inclusive, let it be x. Place all the removed stones on plate x. For every I, find the expected number of stones placed on plate I when all M operations are completed. I think it's true that you can just maintain expected values and do what's written with expected values. So basically, taking the sum on segment, then dividing it evenly and insert value, set value on segment. So that is easily done with a segment tree. No, I think you can do it even without segment tree with set of segments, but it is harder to implement. Especially if you have a pre-written segment tree. Just need to probabilities are sometimes tricky. It might be an what's the word? Not what we expect to see with probabilities. I need to make sure that the expected values will behave correctly. But I think that's true. Basically, we can look at one stone, ignore everything else, and then just look at how the stone behaves. Then our values are basically probability distribution for where the stone is, and you're the probability that for an operation, the probability that we will take the stone is just sum of probabilities here. Everything outside doesn't change. Everything inside becomes equiprobable. So the operation is take sum on segment and then divide it evenly between all the elements in segment. That's for one stone. Now, if we sum it up over all stones because of linearity of expectation, it will be just expected values. So just take sum on segment and do this thing. So that's kind of not an interesting problem. So I guess I will just magic all the pre-written code I need. I need to set in segments, so I need set lazy sec3. Okay, I actually need to implement the values and updates. So update is just set. So when I'm merging two updates, I'm just rewriting the old one with the new one. Okay, so for val, I just need the sum. Is it true? Probably need the size also, because when I apply set value to get the sum, I need to get that value multiplied by the size. So when I'm merging two nodes, I'm just adding the sums and the sizes. When I'm applying update, I'm just setting the sum to update x multiplied by the size. That's it. So I'm getting the sum. That's get r sum. Then dividing it by the number of elements. And then on segment LR, I'm just setting the sum. probably I messed up here somehow. Yeah, I need some dummy state that like update is not active. Because right now I'm saying that the default value of the update is 0, which means set all the values to 0. That's what it did. So yeah, I need to say that the default state is not active, and when I merge into updates, if not a active doesn't do anything, otherwise it rewrites me. And here I'm doing this only if B is active. Yeah. So now here I need to say that it's active and the value is some. It looks alright. The last problem G, 6 seconds. Define strings S0 and S1 as 0 and 1. Given Q queries, process them in order. In the ice query, you are given a triple of integers li, ri, xi. Let si plus 1 be the string obtained by concatenating sli and sri in this order. Find the xi's character of si plus 1. So we're just given strings. Do we need to... Well, we're building some sequence of strings. Each string is concatenation of two previous strings. And then we need to answer what is xi's character. It obviously can be done by just like storing those strings as persistent implicit like trees, like trips. I know that it's like not like very good by complexity. It's not just like logarithm. but I don't know exactly what's wrong there, and I think we would need to like cut those strings by like 10 to the 18th, so that the height cannot become too big. Um, and maybe that's what is expected. Also, like 500,000 is a lot, but maybe we can do it like somehow differently, maybe offline or something. Like we can try to go kind of backwards. Just store the length of each string. That that's just one number, so that we can do, and like cut them by 10 to the 18th. But then we will need to answer the queries. We can like push the query up by the like, build tree, but like in the most straightforward way, we will just like for every query we might need go up q times, right? So that will be like q squared. I just don't want to implement the stupid thing. Um, but maybe that's what this problem is about. I don't know. Okay, well, just yeah, let's treat it as um, persistent implicit trip implementation challenge. I'm not even sure it will work because I'm aware that there is something slightly wrong there. But well, we will try. Okay, so have a node. The node will have left sun and right sun. They might be -1s. It means that there is no such sun. The node will store the character. And the node needs to store the size of the subtree. Oh. Shouldn't matter. Okay. I will have a big array of nodes. How big? Well, I guess how big do you get? We have 1 gigabyte of memory. Each node is 1 to 3 integers and 1 long. So it's like 20 bytes. Maybe it's rounded up to 24. So we have like this many nodes probably. That's kind of scary because even if everything works as planned, like on every operation, I might create height of the tree additional nodes, which like best case scenario it's like logarithm of 10 to the 18th. So it's like I'm creating 60 nodes with every update, and I have 500,000 updates, so that's 30 million nodes, and I have 40 millions just by memory limit. That's not great. I have also heard that like there are better balanced trees that like better suited to this thing. Like you can use something like 233 something. No idea what it is, but I have heard that it is better for this task. No, it's probably some like somewhat standard method, but I don't know it. And it can be just like persistent implicit something. Uh, but I know only of trip and I think that trip cannot fit in memory. This problem. Actually, yeah, I think. So if we do it offline, we build the like DAG of how it goes. We calculate the length of all the strings, and then for every string we have like an index we want to find. Then we can go from like, later strings to earlier. For every string we can like find um, maybe not, but yeah, okay, we want to we can find like in what halves it was split, like how it was built. Then we understand for our query in what half we want to go, like what is the position of the character in that half that we want to look up, and then we like send that query up basically. So the issue with that is that it can go up slowly. Basically, if every string is like concatenation of two previous strings, then we will always send it like one up, and then from the lowest we will send one up. Then on that level we will have two queries now. We'll send those two up. On the next level we'll have three. Send them up. We'll have four, and so on. It will be like q square. But maybe we don't have to deal with them one by one. Instead, we can uh, maintain those queries in some kind of trip or something. Then when we have like queries for this like string in a trip sorted by index, we split that trip in like two halves, like those we need to send to the left part, those we need to send to the right part. For the right part we need to like shift them by the length of the left string, and then we need to send those strips up and merge them like with the existing queries there, which is like the issue kind of. So we're merging some trips and not like merge of trips like this, but they overlap. So we need to like take union of the queries holding and like they should be in sorted order. And if we just did unions, that would be like somewhat fine. Could like merge small to large, and like we would get analog square, but it is actually like if done well, it is analog n, and it was my coursework on the third year in university. But here we're also doing splits before, like we're doing splits, we're doing merges, and I'm not sure if with splits it can be done fast. There was also like a cute problem that we gave in Petrozavodsk training camp like 9 years ago or something, about like maintaining a set of numbers and like there were queries like x, and for all the numbers that are at most x they stay the same, and all the numbers that are greater than x we need to subtract x from them and like maintain a set basically, because I also asked like to print case element at any moment. There the idea was that we look at the blocks like up to x, from x to 2x, and then everything greater. And the idea is like the block from x to 2x, when we subtract x, it will like overlap with block from 0 to x. But then the block that was like greater than 2x, it just shifts and it is like it stays the same and it is not intersecting with anything else. And so that we can do just with merge in trip, and from x to 2x we can insert one by one, because they reduced by a lot, like each one reduced at least twice, so for every element it can reduce like that at most log times, so like, everything would work in analog and log sum. So that was a nice problem. Unrelated to this, just talking about some things I know and did to distract you from the fact that I cannot solve a problem from a coder beginner contest. Is it like solved by a lot of people? is. Amazing. Probably I do not know something that people know. Or maybe just persistent implicit trip forks. Or I don't know. I would not be surprised if like this problem is on library check or something. Because like this problem certainly appeared before. Uh, like maybe in some variation. Uh, maybe it's important that 0, 1. Like 500,000 is a lot. That's the issue. Probably it's important that it's offline, but I also cannot really see how to use that. Oh. I'm like, I was trying to think on the like, for every string, like kind of say that it is built like from the some big block in the middle and then like some smaller stuff on the left and right, and then like merge left and right, and then say that our string is big chunk, uh, something on the left, something on the right. When we merge them, we kind of want to like maintain that structure, and the idea is that like if we need to go into some small things on the left and right that uh, divide the length of the string by at least two, and so like there can be a lot of such jumps, and on the jumps that stay inside the big chunk we can build I don't know, like binary jumps or something, like find like while we are staying in the big chunk we want to find like where we jump and then where we go out of it in like log time, and then there will be log such jumps. But I don't really understand how that would work. Okay, so the contest will end in like 3.5 minutes. If they will post the tutorial right away, I guess I will look at it on camera and see what thing I didn't know. I wouldn't say I'm very much interested in learning what that thing is. Like, seems pretty specific and like, not very interesting to me. But I probably should know it. They don't know how to solve it either. Well, then I don't have anything else for you. Thanks for watching, and yeah, come tomorrow for the Coder regular contest. Bye.